Before we can make a balanced symbol equation, we need to be able to work out what the formula is for each different element or compound in the equation. So before we work out how we can work out a formula, we need to just be really clear on what a formula actually is and what it's showing. So what is a formula? It's something that uses the element symbols to show the relative number of atoms of each element in a substance. So for example, the most common and easiest examples are molecules. And in this case, we're seeing the amount of each atom in each molecule. So the most common example that you'd probably know already is water. The formula is H2O. That tells us that water is made of molecules and each one has got 2 hydrogen atoms, because it's a little 2 after the H, and 1 oxygen atom, because no number after the O means 1. Another example of a common molecule is carbon dioxide, which is CO2. That tells us that each molecule has got 1 carbon atom, because there's no number after it, and that's bonded to 2 oxygen atoms. Don't worry about the fact that I've drawn double bonds there. So there's the formula for these molecules, just to show that it can be the same for more complicated examples. This is still a molecule, it's much bigger. This is caffeine, and the formula for that would be C8H10N4O2. And you can see that if you look and count the different types of atoms in that molecule. So we know that for caffeine, every single molecule has exactly 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, 2 oxygen atoms. There are other examples. There are compounds that aren't molecules. So for example, ionic compounds, this is sodium chloride, which you know as salt, isn't made of molecules. It's a giant ionic structure. It's a solid where there are billions and billions of different ions in rows and columns in 3 dimensions. This is just a small section of it I'm showing. But we can still use a formula to tell us the relative number of each type of ion in it. So if we looked and counted, we'd see that for every 1 sodium ion, there is 1 chloride ion. So the formula for this compound is NaCl. Now, it's not molecules, but we do know that even though there's billions of sodium ions and billions of chloride ions, there is 1 sodium ion for every 1 chloride ion, so just NaCl. A different compound, which is ionic, would be magnesium chloride, which is MgCl2. And that tells us that for every 1 magnesium ion, there are 2 chloride ions. If there's brackets, that's a special case. So for example, calcium nitrate would be CaNO3 and brackets in chemistry are very similar to brackets in maths. It just means that whatever's outside those brackets multiplies everything inside those brackets. So for calcium nitrate, calcium's not in the brackets, so it's just one of those because there's no number. Nitrogen, there's no number after it, but we're going to times it by the 2 because it's inside the brackets. So there are 2 nitrogen atoms there. And with oxygen, 3, but we times that also by the 2, so 3 times 2, there's 6 oxygen atoms in total. So just like maths, times everything in the brackets by the number outside of brackets. And very quickly, just so you don't fall into common mistakes, make sure that you're using your capital and lowercase letters correctly when you're using element symbols. For example, carbon dioxide, you need to have a capital C for carbon and then a capital O for oxygen. If you had CO2 and you accidentally wrote it like that, that looks like a lowercase o. So that's no longer carbon and oxygen, that's cobalt, CO. And cobalt, 2 atoms of cobalt bonded together, as that suggests, doesn't exist like that. So that's definitely wrong. Another really common one that I'll just show you is some people draw quite curly M's. So they'd draw MgCl2, they'd write the formula like that, and they'd say that's my capital M. However, it does look a little bit lowercase like that, so make sure you draw your M's nice and big and spiky so that the person marking your exam paper knows that you meant to put a capital M. And that is how to do formulae.